So hello everyone, my name is Obsttorte and today I want to talk about a script that I have created, one of a few scripts. Just as a reminder, on the wiki page there is a summary of links with links to different wiki articles containing different scripts I have created. And one of this script came up in the newbie dark gradient questions. The purpose of the script was that it checks whether the player looks at a certain object, and if this is the case, something gets triggered. Yeah, and Aosis, I don't know how to pronounce this name. I just say Aosis. Actually came up with this because of something he found in the internet, or when playing Metro last night. I just showed this. And the idea here is that there is a certain type of AI or of enemy which can only be seen in, yeah, don't know how it's called. You can enemy, that is, when you look at it directly, but only if it's in the peripheral area of your vision. So you can see this here. Here's a guy sitting there, and if the player turns towards him, he's gone. And now he's back again. And Aosis, really have to ask him how to pronounce his name, actually want to reproduce this, and thought that the script would be a nice idea. So this is where a little problem started actually, because back in the time when I created the script, or mainly when I create scripts, my purpose is that I say, okay, my idea is that the script serves a certain purpose, and yeah, I then try to implement the scripts in a way that people who want to achieve these effects can simply use the scripts without having to understand how they work. So this is the wiki article about the script, and as you can see here, it says what you have to do. Yeah, you have to create a certain text file and include this line here, and then you can have to set a spawn arc and entity that should react to the player if the player looks at this entity, and then you can set some spawn arcs, and that's it. Yeah. So overall, it's pretty easy setup, and people can pretty easy use it if they really want to achieve this effect. But what Aosis wants is something that is quite similar, but which needs some changes actually. Yeah? And this is a little bit complicated, because this means that you have to understand how the script works. And as said, I just implement this stuff and tell what the script does, but I never really wrote in the wiki articles or somewhere else how the scripts works. And if you take a look at the scripts, you can see here's quite a bunch of stuff. A lot of the stuff is not needed for this particular case, but what is a little bit confusing probably is the math that is involved here. Yeah? There is quite some math going on here, and the problem is the math is not really complicated, but it's not school math, so you don't learn this in school. Yeah? So, and what I want to do now is to basically describe what the script does, and yeah, what's going on there and what the math is, and I hope this will become readable. So, to find out whether the player is looking at something or not, just try to illustrate this. Let's say, oops, here we are. Let's say this is our object, and this is the player. Yeah, let's say P for player and O for object. And now we want to find out whether the player is looking at the object. So what we can easily think of is, and what most of you will know, that each object has an origin. So a certain point in space where the object currently is. So the player has an origin and the object has an origin. And we can pretty easily calculate a vector which tells us what the route is, or a direct straight line is, between the player and the object. So we get an idea, or we can calculate in which direction the object is relative to the player. So, and another thing we can do, and which we can calculate, is in which direction the player is currently looking. Let's say he's looking in this direction. So, and now to find out whether the player is looking at the object, we can easily guess that the viewing direction and the direction from the player to the object should be roughly the same. Yeah? For example, just pick a different color. If the player is looking, for example, into this direction, one could say, okay, he would probably look at the object. So what is interesting for us, or to find out whether he's looking or not, is this angle between those both directions. The direction between the arrow pointing towards the object and between the arrow which pointing towards the direction the player is currently looking. And if these both arrows are pointing roughly towards the same direction, one also say vector, these vectors, then this angle will be relatively small. Yeah, so in this case, this angle is relatively small. Yeah, so we have to somehow find out what the angle is between the direction from the player towards the object and the direction the player is currently looking at. And this is where the math starts, actually. Yeah? To get a vector from the player towards the object is pretty similar. Let's say it's pretty simple. Sorry. Let's say this is vector view. I think it's called view. Yeah. Then view is simply the origin of O minus the origin of P. Let's say these are the origins. Yeah. So the origin of the object minus the origin of the player gives us this vector. This is pretty easy stuff, and this is something that some people might have learned in school even. Yeah? If you have heard something about vectors and about describing points in 2 or 3 dimensions. Yeah. The image I draw here is obviously 2-dimensional because it would be a little bit confusing and hard for me to draw a 3-dimensional. But in the end, in the game, you have to do it 3-dimensional, but it's roughly the same. Yeah. So now the question is how we get the viewing direction of the player, and the problem is that there's no script function that really returns the viewing direction, but the viewing angles. Yeah. So if you take a look at the script, then there is a function called getViewAngles. Yeah. Yeah, you have the description here, returns the player view angle. So this function actually gives us also a vector, a 3-component vector, which describes the rotation. Yeah, because in 2D there's only one possible way how you can rotate something. Yeah, because you're on the plane. You can think of it like with a clock. The arrows on the clock only can turn in one direction if you want. So you can turn clockwise and counterclockwise, but they are moving into this in the same plane. Yeah. In 3D, you have actually 3 different possibilities how to rotate. You can rotate around the x-axis, around the y-axis, and around the z-axis. And as you might already notice, when you, for example, check the doors, if you set them up in dark gradient, then the order is not x, y, z. Yeah. So if you create a door, the typical rotation, which is set by default, is 0, 90, 0. But just write this down, 0, 90, and 0. And this is the standard value which is set for the rotation. And yeah, the door, if this is set, is rotating around the z-axis. So this somehow describes the rotation around the z-axis. So it's not x, y, z. And the idea here is you can obviously describe rotations in different way in 3D, and kind of description which is used here to describe the rotation of the of objects in 3D is the Euler representation. Yeah. This is the German wiki article. I tried to find the English one, but it only showed me in German. And this is a different kind of rotation. Yeah. So the road here, it's basically a rotation about the z-axis, then about the new x-axis, which has then already changed, and then again around the z-axis. So yeah. So what we need to do once we get this Euler angles is that we have to somehow find out in which direction the player is looking at. once we have these angles, yeah, and this is where the real math starts actually. What I did back in the time was to simply look this up, and what you can do here is that you just search it. Yeah, here we have it. That I try to or that there are ways to transform one kind of translation or rotation, sorry, into another kind of rotation. Yeah, and the one we want is this x, y, z, because this is something we can understand. Yeah, and this matrix here describes this, and by default, the player, if all angles are set to 0, this means that the player is looking into the x direction. Yeah, which means he's just looking north, towards the north, and this is represented as my cross. It's a bit lagging here. It's looking into this direction. Yeah. So, and what then happens is that this looking direction, this default looking direction, gets rotated, and this matrix describes how. And as you can see here, the start value only has the first entry set to 1, everything else is 0. So what is important for us is this first column here. This first column describes how this standard looking direction gets transformed by the angles. Yeah. Okay, and you can see here we have basically two different angles which play a role here. And if we, if we take a look at the script, then we can see that this is actually this point here. Yeah. So this player view is actually a value which gets the view angles here. Yeah. And so we have these first two angles which we're actually going to use, and this is just this here. Yeah. So it's basically a very simple transformation. Okay. So once we apply this transformation, we have the looking direction, which is this arrow here, for example. Yeah. So let's call this U. So now the question is, once we have those both angle viewing directions, how we can find out what the angle is between the vector view and the vector u. Yeah. So this is a u. I hope I make it like this. Yeah. So, and there is a mathematical relationship between those vectors and the angle which is spread up by those angles. And this is that the length of u times the length of u times the cosine of the angle, I just call this alpha, equals the scalar product of u and u. Yeah, the scalar product is a component-wise multiplication. Yeah, so just to describe this, you may know this from school. This is the x component, so the first component of u times the times the first component of u plus second component of u, the second component of u. I know my handwriting is terrible. I'm not really used to use this pen here, but I hope it works anyway. And then we do the same with the third component or z component. Yeah, times view z. Yeah, this is actually the scalar product. Yeah, and the value that comes out here is the length of those both vectors multiplied by the cosine of the angle. So we don't really get the angle, but we can get the cosine of the angle. So, and we have some very or some other things we can apply here. This vector here, which was the standard viewing direction, has the length of 1. And if we rotate it, then it still has the length of 1. So this means that this cosine sine stuff here, this here, which I calculate in the script, this stuff here, this player view dir vector, has also the length of 1. So we don't really need u here, yeah? Because u is 1, and if you multiply by 1, then nothing happens, so we can just leave this away. So, and all we still have is this length of u, which is the length of the, or actually the distance between the player and the object he's looking at. Yeah, this is the length of this vector. Yeah, the distance between both origins. And this basically means if we divide this equation by the length of this vector u, then we get the cosine of alpha. And this is what the script actually does. So the script actually says it's a little bit, okay. Script actually uses this, that the cosine of alpha is the scalar product of the viewing direction and the direction towards our object divided by the distance between the player and the object. Yeah, this is what we're going to use here, and we see this in this line. Yeah, I call this angle, but this isn't the angle really; it's the cosine of the angle. Yeah, so we have the player viewing direction, the direction the player is currently looking at, onto, times this shield to player. This is our vector view. I call this shield to player because when I created the script, I tested it with a shield. So the name doesn't make much sense. So shield stands for any object. This is the object the player should look at. Yeah? And shield to player is the vector pointing from the player towards the object. Yeah? And divide this by the length shield to player, which means the length of our vector view, so the distance actually between the player and the object you should look at. And this way we get the cosine of alpha. And this is actually all we do need. We don't really need to calculate the vector alpha. We could do this, but this doesn't make much sense because, as you may imagine, where is my... there. As you can imagine, the angle never gets smaller than 0. It's always bigger than 0, obviously. There are no negative angles here. And the biggest angle possible is 180 degrees, yeah? Which means that the player would look exactly towards the opposite direction than the object is. Yeah? So, and for those of you who might not remember how the cosine looks like of an angle, oops. Okay, this was just do it to here. So we have, let's say, 90 degrees. We have 180 degrees. We have the value 1, we have the value -1. Yeah? And the cosine looks like, oops, this, roughly. Okay. As said, I'm not very good with this pen, but you get the idea. Yeah? So it means basically if the value is 0, the angle is 0, so if you are directly looking at the object, then the cosine is 1. And then it gets smaller and smaller and smaller. And it's 0 if you are looking, so if the angle is 90 degrees. Yeah? And then it gets lower and lower and lower, and it's -1 when we are looking at the opposite direction. So it's actually something monotonous. Yeah. So the smaller the angle is between our viewing direction and the direction towards the object, the bigger the cosine is. Yeah. So if you say we want to have a relatively small angle between the direction towards the object and the direction the player is looking, we just have to make sure that the value is relatively close to 1, which basically means that it should be bigger than something that is a bit smaller than 1. And in the script, this is used by a value, or this is set by a value which is called abs. Abs is something the player can, or the mapper, better to say, can set on the entity. It's a spawn arc, which is called tolerance. And for the abs, we then use 1 minus abs. So the mapper actually sets a small value, relatively close to 0. And then we use 1 minus this small value and get a value that is quite close to 1. The smaller abs is, the closer the final value will be towards 1. And then we just check whether the angle we just calculated, so this cosine, is bigger than abs. So just to illustrate this, we might make this cosine stuff a little bit bigger. I just remove this here. Bam. So so if we have the cosine, let's say like this, yeah, the player gives us an epsilon, and we use 1 minus this epsilon instead. So, and 1 minus epsilon could be here, for example, yeah, 1 minus epsilon. And this means we want the value to be bigger than this. And what we calculate then is the cosine, and if the cosine of alpha is, for example, here, then we consider that the player is looking at the object. I may make this green because it's a positive case, yeah. But if the cosine of alpha is smaller than 1 minus eps, which means somewhere here, then we consider it the case that the player is not looking at the object. And if we use this, oops, yeah. So in the first case, we are something here, which means the angle is somewhere here, yeah, this angle. And in the second case, give me red. The functional value is here, which means we are somewhere here with our argument, and in our apps is somewhere here. So you can see in the green case that the angle, which is this axis here, x is the angle, is smaller than the angle that we wanted to have, which means okay, it is in the tolerance value, the player is looking at the object. And in the red case, where the functional value is smaller than 1 minus epsilon, the angle corresponding to this cosine value is actually bigger. Yeah? So we have the angle alpha here, and this is the cosine of alpha. Yeah? So this means a small angle corresponds to a big cosine. So we don't need the angle itself, we just need the cosine. And this is what the script actually does. There is a few additional stuff going on. The whole thing is activated by a stim. Hence we have this process stim stuff here, we have this set the stim key here, and this response stuff here. This is just because the stim is activating it. We have the possibility to set which stim should activate the object. This is what this is done. If the mapper does not set anything, then this value is set to 23, which is the player stim. This is a stim the player gives up all the time, so it would just react to the player. Yeah. We have a distance value, which causes this to make sure that this is only considered at all if the player is close enough. Yeah. Because if you want that something gets activated by the player looking at it, then the player should somehow notice that he's looking at it. So he has to be close enough. Yeah. So he should not be on the other side of the map. Yeah. Because the script does not take any objects into consideration which might block the view of the player. Yeah. The mapper has to set it up in a way that if this script here gets called, if this whole stuff is processed, then the player can really see the object. Yeah. But this is just some additional stuff. Yeah. And yeah, the rest is calculational stuff. Yeah. We have this shield to player get origin minus inflictor get origin. Inflictor is normally the player. So this is the first equation we had here. Yeah. The origin of our object minus the origin of the player. And then we have this Z component which is decreased by 64 doom units. This is because the origin of the player is at his feet, but we want actually his eyes. Yeah. So hence we change this value a bit. Yeah. These are small things actually. Yeah. The important part is the important part is actually this stuff here. Yeah. This is the important part. This math which is going on here. Yeah. Which we use to calculate the direction. I think there's also a script object. A script function, sorry. Which should roughly do the same. Ang to forward, ang to right, ang to up. Yeah, this actually Ang to forward should give us the first column, ang to right should give us the second column of this matrix, and ang to up, or how it's called, yeah, ang to up should give us this column. Yeah, I didn't use it back in the time because I probably forgot that this or didn't know that this actually existed, so we could make it much easier. Yeah. So and I also think it's possible to get the eye position of the player directly. Yeah. I'm not 100% sure about this though. Yeah. So this is basically what the script does. Yeah. As you can see, it's not that easy to describe all of this, and I'm not 100% sure whether you really understand everything I'm talking about here, because as I said, there's quite some math involved, and I'm actually not used to explain math in English. So but this is what's going on roughly. Yeah. So if you want to alter this, yeah, things will get a little bit complicated, and in this case, yeah, where we want to have this AI to appear and disappear, the object that would react, or which would use the script object, would actually be the AI. Yeah? But the AI is already using a script object which handles a couple of the AI behavior. Some minor things, most is handled by the code, but the script also handles additional things, and we want to have this disappearing thing, like if I remember correctly, it was used in the fan mission Requiem by Goldwell. Is this by Goldwell? I hope this is true, otherwise I'm sorry. Yeah, which is also something I have set up, which also uses the script object. So everything has to, the trigger look script object and this let the AI disappear script stuff has to be merged with the standard script object for the AI to get this to work. So this is a little bit complicated. Yeah. So not the math at all, but the rest. Let's say it's this merging and make sure that everything works fine. Yeah. So this is just an explanation of what the script roughly does, and if you're interested in, I could actually try to implement this disappearing AI and also make a video about it so that you can see how I do this. So you understand what's going on. But yeah, you can post under the video or on the forum whether you want to see it, and you can also post whether this was understandable. Yeah, or not. How long am I talking? Half an hour. Oh, I'm sorry. So yeah, I hope this was somehow enlightening, and I will quit this video now, and you can tell me what you think about it, actually. And stop.